Hello, in this section I will explain how to derive inverse trigonometric function. So at the end of this video, your objective is to find the first derivative using inverse trigonometric rules. So here are the rules for the inverse trigonometric function. If you need to pause it, go ahead. So if you look at rule 1, d of dx, and then you have arc cosine. Did you know that's also the same thing as so whenever you see that arc sign, it's equivalent to saying cosine inverse of x. We could think of that. So yeah, if you see that arc, it's the same thing as inverse. Okay, so it's negative x prime. This apostrophe means prime over square root of 1 minus x squared. Okay. I think I wrote out arc cosine twice. Okay, let's do the other ones. Okay, actually, this one right here, I made a mistake. This should be sine, not cosine, because I wrote it twice. This should have been sine. And this is positive x apostrophe. And then arc cosine is negative x derivative prime over square root of 1 minus x squared. So this should be sine, and then this should be a positive x apostrophe, which means the first derivative, 1 minus x squared. Okay, so go ahead and copy or pause. And then the second half are these ones. Okay, so once you have these down, we can do the problems. Okay, so there are some derivative rules that we have to go over because we'll use these. This first one is the product rule, f prime of g plus g prime of f, quotient rule, and then the power rule. And then I didn't write it down on here, but you also have to know the chain rule because we will use it. Okay, so the chain rule is f prime of g of x times g prime of x. So yeah, we need these rules to do the problems. Okay, go ahead and pause and copy. Let's start doing problems. So let's do example 1. Find the derivative of the function, and our problem is f of x equals 2 arc sin of parentheses x minus 1. So what we could do is 2 is a constant, so we could take that out. So you can rewrite this problem as f of x equals 2 arc sin of x minus 1. Okay, so really we just got to take the derivative of this bracket thing and then bring down the 2. So what is the derivative of this? Well, I do know that what I do know is the derivative of arc sin is x apostrophe or x prime or first derivative, right? 1 minus x squared. Okay. What else do we know? So what would be our x? The thing is, our x is not x, it's actually this whole thing. So our x is actually just going to be x minus 1. And then x prime is just positive 1. Okay, so we have to follow this rule. So it's going to be, so f prime of x equals to 2. And then the derivative of this is x prime over square root of 1 minus x squared. So we said that x prime is 1 over square root of 1 minus parentheses. What is my x value? X minus 1 square. Okay, that is going to be, if I FOIL out this 2, that would be 2 on the top. And then you have 1 minus parentheses. What is x minus 1 squared? So you have to do some FOILing out, but I'm going to do the shortcut. It's going to be x squared minus 2 times ab, or negative 2x, plus b squared plus 1. That's like something you should know. So it's going to be, okay, and then I guess you could put, do you see this minus? Just distribute it. It's 1 minus x squared plus 2x minus 1. And simplify as much as you can. What can you do inside the radical? I believe that the 1s and the negative 1 cancels completely. So you're left with 2 over square root, and then you have negative x squared plus 2x. Okay, so here's your answer. Go ahead and pause and copy, and let's move on. Okay, example 2, find the derivative of arc sin of t squared. So what is the derivative of arc sin? We said, so we know that the derivative, I'm going to always write it down, is x prime over square root of 1 minus x squared. Okay, so the thing is, our x is not x. What is our x? Our x is t squared, right? So find x prime. That would be 2t. Okay, so I think that's all we really need. So you could say f prime of t is x prime, which is 2t, over square root of 1 minus, and then we said our x is t squared, right? T squared. So our x is t squared, and then we have to square that. So that is going to be 2t square root of 1 minus t, and then what's t squared raised to the second power? 4. Okay, copy, and let's move on. So we have example 3, we have g of x equals 3 arc cosine of x over 2. So just like the previous problem, what we could do is we don't have to apply the product rule yet because 3 is a constant. What you could do is take it out. And did you also know that x over 2, if you want, you can rewrite that as 1/2 x, if that makes it easier. So all we got to do is take the derivative of this and then bring down 3. So what is the derivative of our cosine of 1/2 x? Well, I do know that the derivative of our cosine is negative x apostrophe over square root of 1 minus x squared. Okay, so what would is our x? Our x is the x over 2 or 1/2 x. And then x prime is 1/2. So what's the derivative of, okay, so it's 3, and then the derivative of so the derivative of x is 1/2, and then you have a minus, so it's negative 1/2 over square root of 1 minus x squared. So my x is 1/2 x, and square that. Okay. Then FOIL out this 3, so that's 3 times negative 1/2 is negative 3/2. And then this is 1 minus 1/2 x squared is x squared over 4. And then you could simplify this 1 because this is 4 over 4. So this simplifies as negative 3/2. Um, simplify this. What's 4 over 4 minus x squared over 4? That is 4 minus x squared over 4. And then this, you can simplify this. So this would be, we have a complex fraction, so this would be expressed as negative 3/2 over, now this is square root of this whole thing. So this is like, okay, so it's like saying square root of 4 minus x squared over square root of 4, right? That's equivalent to saying this. So this one right here stays the same. You can't really simplify it. Over, we know that the square root of 4 is perfect, so it's 2. So we have a complex fraction. This negative 3/2 is your numerator, and then this whole thing right here is your denominator, right? So let's rewrite it as negative 3 over 2 divided by square root of 4 minus x squared over 2. Then what you could do is cross multiply. So this would be negative 6. And then this is 2 times that. That's 2 square root of 4 minus x squared. And then finally, negative 6 divided by 2 comes out nicely. So here, let me put it here. That is negative 3 over square root of 4 minus x squared. And you have your, this is your, oh, yeah, this is your g prime. Here, this is your final answer. Okay, copy, pause, and let's move on. Okay, let's do example 4. Find derivative we have f of x equals arc secant of 2x. So what is the derivative arc secant of regular x? It is, so the derivative of arc secant of regular x is x prime over the absolute value of x times it by square root of x squared minus 1. Okay. So the thing is, our x is not x, our x is 2x. So x prime is 2. So it's going to be f prime of x equals to x prime, which is 2, over the absolute value of x. So the absolute value of x is absolute value of 2x times it by square root of x squared minus 1. So x squared is, so it's just basically 2x squared. So that is 4x squared minus 1. So this absolute value 2x, I should have just wrote it as regular 2x because the absolute value 2x is just 2x. And then get rid of this 2. So you're left with 1 over x square root of 4x squared minus 1. Okay, so that's your final answer. Okay, so that was, go ahead and pause. Let's do example 5. Okay, example 5 is f of x equals arc tan of x over a. A is like a constant. It's like almost like saying 1/5 x or x over 5. A is a constant. So, okay, so what is the derivative of just regular arc tan of x? It is x prime over 1 plus x squared. Okay, what is our x? Our x is um, x over a, or it's the same thing as 1 over ax, right? X prime would just be, what's the derivative of 1 over ax? It's just 1 over a. So f prime of x equals to x prime, which is 1 over a over 1 plus x squared. So what is our x? It's 1 over a x squared. So that would be 1 over a over 1 plus x squared over a squared. Okay, so simplify the 1 over a. Let's simplify the bottom, the denominator. So 1 plus x squared over a squared. I'm going to add fraction, I need LCD or a common denominator. My common denominator would be a squared. So I guess you can replace 1 with a squared over a squared. So this would be a squared plus x squared over a squared, right? So now what do we have? We have a complex fraction. This is your numerator. This is your denominator. And if you want, let's rewrite this complex fraction as 1 over a then this long sign means divide. A squared plus x squared over a squared. And when you divide when you divide fractions, you cross multiply. So 1 times a squared is a squared, so that will be on the top. And then on the bottom, you'll have a times a squared plus x squared. Right? I'm not going to FOIL it out. I'm just going to leave it like this. And then what do you see that cancels? A squared over a cancels. It just becomes 1. So that's a1 over a squared plus x squared. And yeah, that is f prime of x. Okay. Um, Go ahead and pause, and then let's move on. Actually, let's stop here. Let's break into 2 parts. I'm going to stop here.